All right, Newton's third law, example 2. We're playing pool, also known as billiards. We fire our cue ball. It strikes the 8 ball with a force of 2.9 newtons to the right. If the mass of the cue ball is 0.17 and the mass of the 8 ball is 0.16, determine the acceleration of each ball. Assume no friction. Okay. So I've drawn the two balls interacting here. 8 ball, cue ball. Cue ball is white, 8 ball is colored here. And again, we need to create some letters to differentiate between the two systems. So I'm going to write C for cue ball. Let me just put my paper in the thingy. Okay. C for cue ball, and I'm going to put 8 for the 8 ball. Because I can. You can write E if you want to. So now we're going to write out our givens. We know that the mass of the cue ball is 0.17 kilograms and the mass of the 8 ball is 0.16 kilograms. We don't know the acceleration of the cue ball. We don't know the acceleration of the 8 ball, but we're looking for them. We do know that that the cue ball hits the 8 ball with a force of 2.9 newtons. Okay, what kind of force is that? Two surfaces contact each other. That means it's a normal force, and we're going to call that the cue ball on the 8 ball. And that's equal to 2.9 newtons to the right. Okay. If you want to do it here, you can. You can write that the normal force of the 8 ball on the cue ball is going to be negative, or it's just going to be 2.9 newtons to the left. Okay, because I've kind of, they're equal in size but opposite in direction. So there's your third law. Okay, you don't have to do that in the solution. All right, so it's a normal force because it's two surfaces in contact. We are going to differentiate that between the normal or the regular normal forces in our interaction diagram. Okay, so let's draw two systems, cue ball, 8 ball. They're interacting through this normal interaction. But on a table, they're also interacting with a normal interaction, both balls. And both balls are, of course, interacting with Earth through the gravitational force. Okay? No friction. Okay? And no other rotational forces or anything that will confuse our problem. Alright, so let's draw the force diagrams for these. We have to split it up. So we're going to look at the cue ball and the 8 ball. The cue ball, Fn, Fg. The cue ball, if we go back to our picture, is smacking the 8 ball, and the 8 ball is going to go to the right? So it's going to experience this rightward applied force. And the cue ball is going to go backwards because it experiences that force from the 8 ball. So this is your force. This is your Fn of 8 on C. That's the force that the cue ball experiences by the 8 ball. And this is the acceleration. Okay. Now the 8 ball has a similar picture, except the normal force is going to the right. The other normal force, of course. I think the hardest part of this is trying to keep track of the subscripts. Yeah. Alright, so we gotta set our convention. Positive direction, up and to the right. Alright, so if you put these two together, you look at this like, they're kind of like experiencing these forces all at once during this interaction. All right, each ball accelerates in the direction of its net force due to the normal force upon the collision, or something of that nature. Okay. The assumptions are, as usual, point particle and constant acceleration. And estimation. So we gotta look at the numbers again. About 3 divided by 0.2. That's like 15, I think. So the cue ball is about 15 meters per second squared, and then the 8 ball is smaller, so we'll say like 17 meters per second squared. Cue ball is gonna go to the left, and the 8 ball is going to the right. So let's see what that looks like. I know some of you are going to want to solve this and then go back and put the estimations down. I mean, I guess, but like, do your best to try and estimate these before you start the problem. All right, my tips are gone. Uh-oh. Anyways, I'll work you through this. So we're going to split it up. So cue ball over here, 8 ball over here. Our first step is always to write the net force equation in the direction of motion. So which forces are acting here? So we've got Fn 8 on C. And that is to the left, so that goes negative, and that's equal to MC AC. Okay, taking just this part of the equation, I'm going to solve for AC. So my negative force, 2.9, I'm plugging that in from the given information from before, right? So 8 on C is 2.9 newtons left, so that goes in negative 2.9 newtons divided by the mass, gives me 17 meters per second squared to the left, which is pretty close. The 8 ball, again, we write our net force equation, Fn of C on 8. So whatever the system you're talking about, it should be on that system, the net force. Mass of the 8 ball, acceleration of the 8 ball. So that's the only force acting in that direction. That's equal to ma because we know it's accelerating. So we're going to go A of the 8 ball is equal to Fn C on 8 divided by m8. 2.9 newtons over 0.16 kilograms. And we get 18.1 meters per second squared. 2 significant digits, 18 meters per second squared. Right, that one's to the left. And so we're good. You write your sentence. Now we just have to evaluate size, direction, units. It's going to be very similar to the last question where the size, so let's do direction first. Direction, one is to the left and the other is to the right, so they're opposite direction because Newton's third law says they're going to experience equal but opposite direction of each other. Same direction as F net for both systems, right? The size, so larger mass, let's just check that. So the cue ball had the bigger mass. It had 17 meters per second squared. And the 8 ball had the smaller mass. It had a larger acceleration, so that makes sense. Right, so larger mass, smaller acceleration, smaller mass, larger acceleration. And then finally our units, when we sub them in, it was newtons per kilogram, and that gave us meters per second squared. And as before, we know that those two sets of units are equivalent. All right, not bad for first time videoing, I hope. I hope you guys were able to follow that. If not, of course, always send me your questions. We can video chat or whatever it is to help you out. But for now, can't see this, but it's on your page. Textbook questions for Newton's third law, page 140, 1 to 4. And page 141, it's 6, 7, and 9. Okay, good luck.